So we're going to be talking about the graphs of absolute value functions. And all absolute value functions have the same basic shape. They're just manipulated a little bit depending on what else is in the equation. Our basic absolute value function is this right here. Y equals the absolute value of x. And the way that this is graphed is like this. Looks like a big V. And really what it means is, and this is something we call a piecewise function because it comes in pieces, is that the absolute value of x is x if x is positive, so if x is greater than or equal to 0, and it's negative x if x is less than 0. And so absolute value of, let's say, 3. Absolute value of 3 is 3. So here we have the point 3, 3. That's on our graph. If we have negative 2 for x, we put negative 2 in there, we get 2. So our pair of coordinates is negative 2 for the x and 2 for the y, which is right here. So if you did this for infinitely many points, you would get this entire V-shaped graph. And all absolute value functions look basically like this. But they're manipulated. And we do that using something called translations. So if we go to the bottom of the page and it says, how do I graph this? Y equals the absolute value of 2x plus 5. All right? And the answer is using translation. All right? So here's basically how translation works. All right? If I have y equals the absolute value of x, and I add some number c to it, all right? And remember, c is positive, so if I add a number to it, it shifts the function upwards on the graph. That many units. However many units c is, it shifts it up. So the whole thing is going to go up. So on my graph, I have y equals the absolute value of x. If I go to the end of my function, and let's say I'm going to add 3 to it, it moved it up 3 units. Okay? So it's still the same shape, it just got moved. So this is the absolute value of x plus 3. Now, the same thing happens, but in reverse, if I subtract a number from the function, it's going to shift it down. All right? It's going to be the same V shape, but it's going to shift down. If I put that number inside the absolute value bars, and the number is positive, it's added, it's going to shift it to the left. So if I go back to this particular graph, and let's delete that plus 3, and I'm going to go inside my absolute value bars, and I'm going to put plus 2. You'll see it shifted 2 units to the left. And you can tell by where that point is. It's shifted 2 units to the left. So if I add a number to it, it shifts to the left. If I subtract a number, it's going to shift to the right. All right, so I can graph any absolute value functions just using these shifts. But we have the benefit of our graphing calculator on our iPads. And it's okay to use that, okay? Because there are a lot more shifts. All right, the next box has what we call vertical and horizontal stretching and reflecting. And again, I've got C, but this time just know this, C is greater than 1, okay? If I have a number c out in front of the absolute value of x, what this is going to do is stretch it vertically. So let's put in something here and see what's going to happen. I'm going to back off my plus 2 that I had here, and I'm going to go, see if I can go in front, here we go, and I'm going to multiply it by 2. And see how it got skinnier? It stretched it vertically, all right? Now, if I put a number there, actually you'll see this in your translations, 1 over c, which is essentially a fraction, so 1/2. And I can do this by using it as a decimal, using 0.5. So let me back this up, and I'll put in 0.5. See how it stretches it this way. It makes it flatter. It stretches it horizontally. All right? So that's what happens if you have a fraction less than 1 in there. If you have the C inside, it's going to shrink it horizontally. If you have the C in the denominator inside, it's going to stretch it horizontally. And we can do examples of this. If I put a negative in front of it, so here's what I'm going to do. We'll try this one. I'm going to go back. I'm going to put a negative in front of it. It flips it upside down. So it reflects it. We call that reflecting on the x-axis. The x-axis is that horizontal axis, and it reflected it to the other side, just like a mirror. All right? So we call that reflecting on the x-axis. All right? Here's what happens if I put it inside. It's going to reflect it about the y-axis. But here's what you're going to notice. All right? If I reflect it about the y-axis, it's going to flip this way. All right? So let me go get inside here again. Let's see if I can. Oh, there we go. I put the negative in there. Notice, it landed right back on top of itself. So it landed right on top of itself. So you don't see any change. So essentially, it's the same thing. Now, these reflections hold true for all types of functions, not just absolute value functions, but quadratic functions, linear functions, exponential functions. So the translations hold true. What we're going to be doing today is we're going to be using these to graph. All right? When we do this, there's a little procedure we have to go through, because this is not an easy one to graph. The very first thing we've got to do here is we have to factor out that 2 that's in front of the x. And you'll remember doing this from Algebra 1. Remember we would factor out the greatest common factor? Well, we're going to factor out 2, even though it's not the greatest common factor. When we factor that out, we get 2, and in parentheses, x plus 2.5, because 2 times 2.5 is 5. All right? Now we're going to use our translation. The 2 that's in here, if I go up here, says it's going to shrink it horizontally by a factor of c. Shrinking horizontally means stretching vertically, okay? It means if it's shrinking horizontally, it's stretching vertically. The other thing is I've got a plus 2.5. That's going to shift it to the left, 2.5. And what we end up getting is this. It shifted to the left 2.5, and it became longer. All right? So here's what I've got. I've got a very complicated one here. I've got stuff on the outside. I've got stuff in the inside. I've got a negative, but that's okay because we have this fantastic thing here. So we're going to do a couple of things, and we're going to evaluate what this looks like. So first of all, inside, I want to factor out whatever is with my x. So when I do that, I'm going to have this. Y equals 3 minus the absolute value of 1/2. And what would go here? What times 1/2 gives me 2? 4. Okay, so the 4 minus 4 tells me it's going to shift right. All right, the minus 4 tells me it's going to shift right. The 1/2 that's in front of here tells me it's going to stretch horizontally. So it's going to become long and fat. All right? Let's put this short and fat. We've got a negative in front of the absolute value bars. And if we go about up to the top, we remember that means it's going to reflect to the bottom side of the y or the x-axis. It's going to flip it upside down. So reflect on, I'm sorry, the x-axis. So we're going to do that. And then if we have a 3 in front, that's like a plus 3. And the plus 3, we said, is going to shift it up 3 units. So it's going to go up 3. So let's do this. Let's see if we can put this in our calculator and see if we can get this to graph. So let me move this because I'm never going to remember this function. All right, so here's what I've got. Delete that. I'm going to go out in front here, and I'm going to put in 3 minus. Notice, the 3, as soon as I put it in, it shifted it up. And when I put that minus in, it flipped it over, upside down, right where it was at. Notice that? Right away. So now, let's go inside of here. And what I've got to do, when I put in the x over 2, I need it to be in parentheses. So I'm going to delete the x, and this is all going to go away for a second. So parentheses, x divided by 2. All right, now I can go outside of the parentheses because I've got the x over 2. And notice now how it went flat. And then I've got minus 2. And remember, minus 2 is going to send it to the right. So minus 2. And it shifted it over to the right. Pretty cool, huh? And there we go. That is our graph. It's still that same V. It's just shifted